Is my screen is visible to you now? Hamna?
Yes, sir.
Okay, tell me. A particle is moving in a circular motion of radius r. The displacement after half of a circle would be. Tell me, what should be the answer of this question? A particle is moving in a circular path of radius r. Tell me, beta. Is it tough?
Two R C.
The particle is moving, okay, in a circular path. Okay, then its displacement after half circle will be 2r. Very good. Move to the second question. Solve the second one. Okay, sorry for that. What would a body thrown vertically upward with velocity, initial velocity, with velocity u, the greatest height is h to which it rise. If the height is greatest, the greatest height is h, then to which it will rise. Tell me, what will be the value of h?
B.
B. Okay. Wait a minute. Okay, how can you say that it would be B? Did you solve this one or not? Did you solve it? Hamna, I'm asking you something, beta. Okay, let's assume that it would be B. Let me check. I'm going to check your test. I'm going to take your test. Okay, the B is the correct option for second. Okay, do the question number third. Let me check. Do the question number third. Okay, then I will check your answers. Is the screen is visible to you? Hamna, tell me.
D.
Okay, D. Okay, the D is the second, your option of answer of fourth. Okay, so let's move to the next question. Okay, what will be the next question? Okay, solve question number 4 and 5. Tell me, Hamna. Question number 4. Okay, let's discuss. Let's discuss. So according to you, your questions was, wait a minute. According to you, you said that B is the correct answer for this question, na? For this second one. Hamna, tell me. Hamna, is I'm audible to you? Hello. आवाज आ रही है आमना? Is I'm audible? You told me second option is D. So why are you not replying? Okay, let me set it to you. So let's solve this question. So what he is saying in the question is that in the question it is being given that right. Okay, a body is thrown vertically upward with a velocity u, means its initial velocity u, and it is being asked that what will be the greatest height it reached. What should be the greatest height it reached? So we have the formula that if the time is not being given to you, we know that the when a body reaches to its final position, its toppest height, then its final velocity will become 0. We have the height as h, or displacement as h. Okay, acceleration due to gravity is g. Okay, and that will be considered as negative g because it is upside, moving upward. Okay, and we have the v square s, and we don't have the time right now. Okay, so we have only an initial velocity is u. We have initial velocity is u, so we have v, s, u, and t. We do not have t. So actually we will use this equation: v square is equals to u square plus 2as. Okay, so from this equation we can calculate the value of h. So we can write here v square is equals to u square plus 2gh actually. So we can write like this way here. Okay, now you have to write here that since it at the highest point its initial velocity will become 0. So we can write here 0 u square plus 2 minus g into h. H is the height. Okay, So when this u will comes to that side, it will become a minus u square is equals to 2gh minus 2gh, minus minus will cancel out. Why g is I'm taking negative? Because when the acceleration, when the object is moving upward, then its acceleration will be considered as negative. Now you need to calculate the value of h only, so that will be vu square upon 2g. Okay, u square upon 2g. So u square upon 2g means b will be the correct option for this equation. So copy this one, फटाफट से copy this one. Because in this half yearly examination, we'll be going to have only objective questions. Copied, Hamna?
Yes, sir.
Okay. The numerical ratio of the displacement to the distance for a moving object is, the numerical ratio for the distance always, if I'm talking about the always, so the numerical ratio means if I'm moving like this, okay, if I'm moving like this, so this is a displacement, and sorry, distance, this is a distance, okay, and but if I need to calculate its displacement, that will be this one. Displacement is, so we generally consider that displacement is lesser than, displacement is lesser than distance. Okay, distance is always greater, but always cannot be not considered, because if our object is moving in a straight line from a to b position, okay, if an object is moving in a straight line from a to b position, then we can say that here, if he is moving from a to b in a straight line, then its distance and displacement will be same, and displacement both will be same. Okay, now the ratio of the displacement, we are talking the displacement as above, and we are talking about the distance, and in the denominator we are keeping the distance, displacement at the top and distance at the in the numerator. Okay, so we know that this, if they both are equal, means the distance and displacement are equal, so we can consider this one 1 upon 1, that will be equal. The both, if I'm saying that an object is moving in a straight line, okay, from a to b position, and this, let this object, this distance is 5 meter, so the distance and displacement will be same, so we can write here 5 by 5, the ratio will be 1, means it will be equal. And in case if an object is moving like this 5 meter from here and 5 meter from here to here, then in that case its displacement will be 5 root 2, which is lesser, and distance will be 10 meter. So we can write here 5 root 2 when divided by 10. So here we say that the denominator is greater and the numerator is smaller, so the answer will be less than 1. Why the answer will be less than 1? Because the numerator is smaller than the denominator. Whenever we have the numerator smaller and denominator greater, then in that case the fraction is going to have a value less than 1. So we can say that it will be equal or less than 1. B will be the correct option. Okay, got it, Hamna? Got it?
Yes, sir.
Question number 4. If the displacement of an object is proportional to square of its time. Okay, let's talk about this one. Okay, so if I'm talking about if the displacement of an object is proportional to the square of time, then the object move with, tell me, you told me that if the distance and the displacement is proportional to the square of the time, then the object moves with, uniform velocity, uniform acceleration, increasing acceleration, or decreasing acceleration. So what is it? What we are saying that here is that if the displacement of an object is proportional to square of time means, if I'm saying that square of time means, if I'm writing here displacement, okay, and it is the square of time, okay. For example, if I'm writing here, it's proportional to the square of time, not the time, okay. So if I'm saying here displacement, and if the square of time is t square, and if I'm moving like this, so for example, if I'm saying here in 1 second, 2 second, 3 second, 4 seconds time is taking, so I can write the time square will be 1, then 4, then 3, the square of 3 is 9, the square of 3 is 9, and then square of 4 is 16, then 25, means it is not covering equal distance in equal time of intervals. For example, if I'm writing here, let me explain you here with in great detail. Okay, let me explain you. Wait a minute. Let me explain you here. Okay. So for example, if you are having a graph like this, okay, and if I'm saying that the displacement and square of time, an object is going covering a distance proportional to square of time, okay. So if I'm writing here, this is 5 meter, this is 10 meter, this is 20 meter, sorry, this is 15 meter, and this is 20 meter, okay. And if I'm writing here 1, then if I'm writing here 4, then if I'm writing here 9, and if I'm writing here 16, and if I'm writing here 25, so then it will be a straight line. Means an object is covering 5 meter in 1 second, then another 5 meter in 4 seconds, another 5 meter in 4 seconds, another 5 meter in 9 seconds, another 5 meters in 16 seconds, and another 5 meter in 25 seconds. So it means its speed is decreasing constantly. 1 meter in 5 seconds, then another 5 meters in 3, he is taking 3 seconds, another 3 seconds. For another 5 meter, he is taking 3 seconds. Then for another 5 meters, he is taking 5 seconds. Here it is, he is taking 5 seconds. Here he is taking 7 seconds. Here is taking he is taking 9 seconds. Okay, 9 seconds. So since we see that we are watching here that he's taking more time to cover the same distance, so we can say that its speed is decreasing, and we can say that it is having a non-uniform motions. Uniform motions means if it is covering equal distance in equal time of interval. So if an object is covering equal distance in equal time of interval, we consider it as uniform motion. Otherwise we will consider it as non-uniform motion. So this will be non-uniform motion. Got it? Or having some doubt regarding to this? Got it, Hamna?
Yes, sir.
So this is a uniform, okay, uniform acceleration, uniform increasing or decreasing acceleration. Okay, so we can say that it is decreasing acceleration, since proportionate of time, we can say that its acceleration is decreasing and speed is constantly decreasing, okay, with time. Got it?
Yes, sir.
Let's move further. Here we see that in the VT graph, it can be inferred that the object is, but you can see that it's in uniform motion, at rest in non-uniform motion, moving with uniform acceleration. Tell me, this is simple graph. What this in question number 5, what should be the correct option? The Samna, in question number 5, what would be the correct option? Tell me, in question number 5, what should be the correct option? Your voice is not audible, Hamna. Tell me.
B, sir.
B, at rest. Check it again.
D.
D, moving with uniform acceleration. No, here the acceleration is 0. The velocity is not changing with time. Here you see that velocity is not. Let's suppose if it is a 50 meter per second, velocity is 50 meter per second. So in time, say 1 second, 2 second, 3 second, 4 second, 5, 6, 7. Every time you will find that the speed is 50 meter per second. It is not changing. When the speed is not changing means we have uniform acceleration. Sorry, we have zero acceleration. And zero acceleration means that the speed is not changing. Accelerated motion, what are accelerated motion? The speed must change with time. They are called the accelerated motions. But here we see that neither the speed is increasing nor decreasing. It is moving with a constant velocity, okay, with time. So this is considered as uniform motion. Uniform motion. Okay, got it? Or having some doubt? Got it, Hamna? Got it? Okay. So let's move further. Let's move further. So moving towards the next questions. Sir, class में होगी करता हूँ बाद में. Hello. Hello. G. Let's move towards the next question. Here is the question number 6. Tell me, suppose a boy is enjoying a ride on merry-go-round, which is moving with a constant velocity of 10 meter per second. It implies that the boy is at rest, moving with zero acceleration, in accelerated motion, or moving with uniform velocity. Suppose a boy is enjoying a ride and which is moving with a constant velocity of 10 meter per second. It implies that the boy is at rest, moving with no accelerations, is in accelerated motions, moving with uniform velocity.
D.
Okay, we can say that D is the correct option. So here we can write here D is the correct options. Okay. Okay. Area under VT graph represent which physical quantity? Area under VT graphs represent which physical quantity? Tell me.
D.
D. Area under VT graphs represent physical quantity. So we know D. You are saying D. Area under VT graph. Area under VT graph. Area means product. Area means, you just understood that for simplification that area means product. Okay, so what does V into T means? Which physical quantity will it give it to you when V is multiplied by time? When velocity is multiplied by time, which physical quantity will you get?
Displacement.
Displacement. Okay, the unit of displacement is SI. Unit of displacement is, tell me, the SI unit of displacement is?
Meter.
Okay, so meter will be the correct option. Okay, question number 8. Four cars A, B, C, D are moving on a level ground. That their distance, whereas time graph shown is shown. Okay, which here it is. Choose the correct statement. A car is faster than D. B is slowest. B is the slowest. D is fastest. Then car C. Car C is slowest. Tell me which will be the correct option.
D.
D. Okay, D. The correct option is B. B. Car B is slowest. In displacement or distance time graph, lowest the angle with time axis, slowest is the car. Okay, so we can say that B is slowest because it is going to have the lowest angle with time axis. Then A, then D, and the fastest is C. Fastest is C. Okay, got it? Got it, Hamna? Let's move towards the next question. Which of the following figures represent the uniform motion correctly? Which of the following figures is representing the uniform motion correctly? A, B, C, D. Tell me, Hamna, which of the following is representing the correct uniform motion? You are saying A. Okay. Question number 4. Question number 10. Okay. Question number 10 is here. Sorry. Uh, there are the 2 10 questions. Okay. The slope of velocity time graph gives what? Slope of velocity times graph give what? Distance, displacement, acceleration, or the speed? Tell me the answer.
B.
D. The slope means division. You need to keep in mind slope means division. You can write here division, and area means product. You can write here. You can keep in mind that if it is being asked that what the velocity area under VT graphs will give you, so what you need to do is V into T. You will give whatever the products count, that is displacement, so it will give you displacement. Okay, and slope means division. Division means when velocity is being divided by time. Okay, okay, it is acceleration. Okay, then it will gives you V by T will gives you acceleration. Rate of change of velocity is called acceleration. Okay, let's move towards the next question. Question number 11th. In the following cases, in which of the following cases of motions the distance moved and the magnitude of the displacements are equal? Which of the following in which of the following the motion in which of the following cases of motion the distance moved and the magnitude of displacements are equal? I have given you the examples. If the car is moving on a straight road, if the car is moving in a circular path, if the pendulum is moving to and fro, the earth is revolving around the sun.
A.
Okay, if an object is moving in a straight line. Okay, okay, the displacement of a moving object in a given time interval is 0. uh, would the displacement traveled by the object is also 0? Justify your answer. The displacement of a moving object in a given time interval is 0. Would the distance covered by the object can also be 0? He's saying object is moving, it is not stationary. You need to keep in mind object is moving. So how will you explain this answer? Tell me, Hamna, how will you explain this one? Tell me, Hamna, if in what case the displacement of an object is 0 If an object is moving, and can we say that its distance travel will be 0?
No.
So in what case, justify your answer. How can you say that it is no? How can you say that it is no? Tell me. Because if an object is coming, or if the objects moves and comes to its original path, then its displacement will be 0. But its path length is not 0, because the distance, we can say that distance is total path length covered. For example, if an object is moving in a circular path and come its original position, then its distance displacement will be 0, because it's come to its original path. But its distance traveled is 2 pi r. 2 pi r. Okay. 2 pi r. Okay. Or we can say that if an object is moving in a straight line and come back to its original position, then its displacement will be 0. But in case of a distance travel will be twice of the distance between the 2 points. Okay. So this type of displacement, this is the way that how can you explain this question, this answer. Okay. Next is, how will the equation of motions of a moving object is uniform velocity change? It is being asked, how will the equation of motion for an object moving with uniform velocity change? How will be the equation of motion? So we have the three equation of motions. We have the v is equals to u plus at. V is equals to u plus at. We have the another equation, that is s is equals to ut plus half at square. S is equals to ut plus half at square. And we have the v square is equals to u square plus 2as. So but actually when if an object is its velocity is not changing, so we can say that it is going to have acceleration 0, a is equals to 0. By putting the acceleration is equals to 0, the first equation will become v is equals to u, the second equation will become s is equals to ut, and the third equation will become v square is equals to u square. Okay, got it, Hamna? Got it?
No, sir.
No. If I'm saying that how will the equation of motions of an object moving with uniform velocity change? If I'm saying here that how the equation of motion, if an object is moving with uniform velocity, what does it mean? If an object is moving with uniform velocity, it means v minus u is 0. Uniform velocity means if its initial velocity and final velocity is same. If it is moving, for example, 50 meter per second, so its initial velocity is 50 and final velocity is 50. So this will be 0. So change in velocity is 0. Change in velocity is 0 means acceleration is 0. So when you put the acceleration value is 0, so 0 into t, it will become 0. So we will have v is equals to ut. Sorry, v is equals to u. The second equation is s is equals to ut plus half at square. So this whole will become 0. So we will have s is equals to ut only. And here v square is equal to u square plus 2as. So here this quantity will become 0, because 0 into 2 into s, it will become 0. So this will be u square is equals to uh, u square is equals to v square. Okay. So yeah, v square is equal to u square. Sorry. Got it?
Yes, sir.
Okay. In the third equation of motion, sorry, in question number 14, a girl walks a straight path to drop a letter and comes back to her initial position. Her displacement time graph is shown in the plot. In this one is his displacement time graph. It is being given. Okay. Plot the velocity time graph for the same. You have to plot the velocity time graph for the same. So what would be its velocity in the from 0 to 50 seconds? If it is covering 100 meter in 50 seconds, then what would be its velocity? Tell me, Hamna. Hamna, tell me, beta. How will you make such type of graph? Velocity time graph. Hmm? Okay, let me explain you one thing, that if an object is moving from A to B position, okay, and if I'm considering that its velocity is positive v, so when it will comes from B to A, then its velocity will be considered as negative. Okay, so how can you explain this in VT graph? Let me explain you. Okay, so this is 100 meter in 50 seconds and another 100 in, okay, so let me explain you this one here. Okay, if an object, this one is an object, okay, this is the displacement time graph, that is I'm making the previous one, displacement time graph. Okay, so he is moving 100 meter in first 50 seconds. Okay, in first 50 seconds, and then she is returning back. So in another 50 seconds, he is returning back, and its displacement will become 0 in another 50 seconds. Okay, her displacement become 0 in another 50 seconds. So this will be total in 100 seconds, displacement will become 0. Okay, so because she is returning to original path. So how can we make this? So we can calculate the displacement. First of all, velocity. So velocity is equal to displacement upon time. Displacement, velocity is equal to displacement upon time. Okay, so for V1, velocity when she is moving to the post office, her velocity is, displacement is 100 meter and time is 50. So 100 upon 50, you can say that it is 2 meter per second. Okay, positive one. And when she is returning back, so we can write here, because since the distance will be considered, displacement will be considered it as negative. Why we are considering the displacement as negative? Because you can see that here she is returning from from post office to home. So if she is moving from A to B, so because suppose this is her home and here it is 100 meter and this is post office. So if she is moving from A to B position, okay, then we will be going to have 100 meter. Okay, and this will be considered as positive displacement. But when she is returning back, so since displacement is a vector quantity, so this will must have negative 100 meter. Will be considered this one as negative 100 meter. If we are considering this one this side as positive, then other side will be considered as negative. So if I'm considering the first moving velocity is 2 meter per second, then another will be considered as minus of 2 meter per second. So the graph for this equation will be like this one. This one is 0. This one is positive 2 meter per second. Positive 2 meter per second. And this one is negative 2 meter per second. Okay. So for the first 50 seconds, she is going to have the constant velocity of 2 meter per second for the first 50 seconds. And for the next 150 seconds, she is going to have another velocity that will be minus of 2 meter per second. Okay, minus of 2 meter per second. So her graph will be like this. Got it? Got it, Hamna? Hamna, are you there in the class?
Yes, sir.
You got it?
Yes, sir.
What does this minus 2 meter per second representing here? Why add it here minus 2 meter per second? Because she is returning home, so its velocity will be considered as negative. If she is moving with 2 meter per second initial velocity, then when she comes back, it will be considered as minus 2 meter per second. Okay, so since for the first 50 seconds she is going to have positive 2 meter per second velocity because she is moving to the post office, and when she will be coming back, so since velocity is a vector quantity, it has a direction as well as magnitude. So if I'm considering its velocity from home to post office as positive, then its post office to home velocity will be considered as negative. So here the velocity is minus 2 meter per second. So we have this graph. This is showing that this is positive 2 because this is the y-axis, and this is representing the velocity. This is velocity, and this x-axis is representing the time. So in 0 to 50 seconds, from 0 to 50 seconds, this velocity is positive 2 meter per second constant. In 1 second, 2 second, 3 1 second, 1.5 second, it is still 2 meter per second. Okay, but when she start returning home after the 50 seconds, her velocity becomes minus of 2 meter per second, and this minus of 2 meter per second remain from 50 to 100 seconds. Okay, got it? Got it, Hamna?
Yes, sir.
So this is the velocity time graph representation. Okay, let's move. Here we have the question right now. A car starts from rest and moves along the x-axis with a constant acceleration of 5 meter per second square for 8 seconds. If it then continued with constant velocity, the distance will be that what distance will be covered with the car in 12 seconds since it started from the rest? Tell me. Question number 15. Have you solved this one? Hamna, you're not responding. Tell me, are you solving this one or let me solve it for you?
I am solving.
Yeah, solving. Okay.
Sir, 30 meter.
30 meter. A car starts from rest and moves along the x-axis with a constant acceleration of 5 meter per second square for 8 seconds. Okay. If it continues with a constant velocity, if then it continues. Okay, for the 8 second, for the first 8 second, its acceleration is, we can consider its acceleration is 5 into 8. Sorry, the distance covered will be, we can calculate the first distance. So distance, displacement in 5 seconds. Displacement in 5 seconds. Okay, so what will be the displacement in 5 seconds first? Have you calculated this one? So first 5 seconds. So you can make the graph, or you can make the as you can solve it by graph, making graph, or you can solve it by doing simple equations. Okay. So when we have the velocity time graph, or you can have the distance time graph, the distance time graph, or we can have the velocity time graph, velocity time graph. Okay. So you need to calculate actually the displacement. So we can, okay, Hamna. Okay, Hamna. So we have the displacement time graph right now here. Okay. So we are making here. So the object is moving at 5 meter per second initial velocity. Okay. So yeah, we can have the acceleration time graph also, or you can solve it by simply using s is equals to ut plus half at square. So for the first 5 seconds, sorry, 8 seconds, its initial velocity is 0 into t. So this will become 0 plus half into acceleration is 5 and t is 8, 8 to the 64. So displacement in first 5 seconds will be 864, 64 when divided by 2. So it will get 32, 160. So 120 half into 5 into 64. When you cut it, you will get 32. 32 when multiplied by 5, you will get 160. So in first 5 seconds, it will the car will cover 160 meter distance. And then if it continues with a constant velocity, means the velocity, what first we need to calculate what would be this velocity at the end of 8 seconds. What distance will it covers in 12 seconds since it is started, means you need to calculate first its final velocity when the car is going to have in its 8 second. Okay, so we can calculate its final velocity. V is equals to u plus at. So we can write here initial velocity is 0, a is 5 and time is 8. So its final velocity is 40 meter per second. Okay, so the car is moving with a speed of 40 meter per second for the next 4 seconds, because 8 up to 8 seconds it has traveled already 160 meter, but now the speed is constant. So in the next 1 second it will cover 40 distance. It is 9 second. Then in 10 second it will cover again 40 meter. Then in 11 second it will cover again 12 meter, and in 40 meters. Then in 4 second it will again cover a distance of 40 meter. So in next 4 seconds, means 9, 10, 11, 12. So in next 4 second, next 4 second, next 4 second, the car will cover 40 into 4 is equals to 160 seconds, 160 meters. So it has already covered 160 meters when it from in between from 0 to 8 seconds, from 0 to 8 seconds, and from 8 to 12 seconds it has covered another 160 meters. So the total distance covered will be 320 meters. So the right answer for this will be 320 meter. Okay, got it, Hamna? Hamna, got it? Or still having some doubt? Hamna, got it? I'm asking, beta. Okay, that's all for today. We'll meet you in the next class tomorrow. Thank you so much for joining this class.